Welcome back to the second part of chapter number 10 in this lecture series on CCNA Cybersecurity Operations with me, Joachim Kjærestad from the University of Skövde. In this second part, we will talk more about endpoint vulnerability assessment. And we will talk about things like profiling, the CVSS or Common Vulnerability Scoring System. And I will also talk about some standards and frameworks that you can follow when you do your vulnerability assessment work in your client or your endpoint protection strategic work. So let's begin with network profiling. And as I mentioned before, a key aspect in trying to detect abnormal behavior is to understand what normal behavior is. So the idea is that we understand normal behavior so we can find what deviates from that normal behavior. And network profiling is used for this, and it's essentially about establishing a baseline of normal network behavior. And to do this, you can use tools such as Wireshark and NetFlow, and the idea is that you characterize network traffic. So you, for instance, establish a baseline of used ports, throughput, bandwidth utilization, what IP addresses that are used, and so on and so forth until you have a layout of how the network is commonly used. Likewise, we have server profiling, which is done with the same purpose as network profiling, but for servers. Some of the metrics that we list here is what ports the server is listening to, what user accounts that are using the server, what service accounts there are, what processes and tasks that are running. And as I said, anomaly detection involves detecting behavior that differ from the profile. So when something happens that is not part of the profile, we know that something may be wrong. So next slide here is about vulnerability testing. And network security can be tested using a variety of tools and services, and there are various types of tests that you can perform to have an idea of the security level in your network. So the idea is essentially to do a health check in different ways. The three activities that are mentioned in the material are risk analysis, vulnerability assessment, and penetration testing. Risk analysis is when you conduct a comprehensive analysis of impacts of attacks that can happen to your company. So you basically think about what assets you have and what possible risks there are towards those assets, and you rate the impact that an attack on those assets or functions would have. So to do this, you can use internal or external consultants and risk management frameworks, which we will talk a little bit more about at the end of this lecture. Vulnerability assessment is, for instance, patch management, host scans, port scanning, or using different scanners and services to essentially technically assess what vulnerabilities that you can find in your network. And there are some tools for this: Microsoft Baseline Analyzer, Nmap, and more. And finally, we have penetration testing, which is perhaps the most aggressive way of vulnerability testing. And this is the use of hacking techniques and tools to try to penetrate network defenses. And the idea here is basically that we try to hack a network in order to see how easy it is, and in that way detect vulnerabilities. And some of the tools we can use is Metasploit, Core Impact, or we can employ ethical hackers to do the work for us. So moving on then to the Common Vulnerability Scoring System, or CVSS. What this is a risk assessment designed to convey the common attributes and severity of vulnerabilities in computer hardware and software system. So it's essentially an open framework that is vendor neutral, that is used to identify and score vulnerabilities. It's become the industry standard for weighing the risks of a vulnerability, and it uses a variety of different metrics, as we will explore a little bit next. So the different metrics that you can assign to a vulnerability will be combined into a score, and the score should be a score of the risk inherent in a vulnerability. So let's use the next few slides to have a small overview of how CVSS is built and how it works. And if you want all the details, you have to refer to the written material. So essentially, CVSS uses three different groups of metrics to assess a vulnerability. So first we have the base metric group, and the base metric group is essentially characteristics of a vulnerability that will be consistent over time and across different contexts. So whenever you find a vulnerability, the metrics or the characteristics of this vulnerability that will remain the same are in the base metric group. And it has two underlying classes: exploitability, which is the features of the exploits, such as vector or complexity, the level of user interaction required by the exploit, stuff like that. And then we have the impact metrics, metrics that describe the impact of the vulnerability, and those are rooted in the CIA confidentiality, integrity, and availability triad. So then we have two more context-dependent metric groups, where we begin with the temporal metric group, and this measures the characteristics of a vulnerability that may change over time, but not across user environments. So we are still on metrics that will be the same no matter what user environment we are in, but we are looking at metrics that may change over time for various reasons. So for instance, it may be an operating system dependent metric or a vulnerability that or a characteristic that will change when the operating system updates or whatever. So finally, we also have the environmental metric group, and this measures the aspects of a vulnerability that are rooted in a specific organization's environment. So here we can apply characteristics that are organization or network specific. So let's start looking at the process just briefly. So when scoring a vulnerability, it's assigned a score for each metric and then each metric group, and then all scores are combined into one final rating. So the base group will yield a base score. And then we can apply the temporal group score, which will yield a temporally adjusted score. So it's a base score adjusted for the metrics in the temporal group. And then we can also apply the metrics from the environmental group, and then we'll get an environmentally adjusted score. So combined, you can either see the vulnerability score as a baseline. You can see it as something that is as a score that is that is adjusted for how it is in a certain time, and you can also have a score that is adjusted for a certain environment. And essentially, the final rating will be something between 0 and 10, which can be converted into a rating from none to low to medium to high to critical, as in the table in this slide. And the idea is that basically everything with a rating of medium or higher needs to be taken care of in one way or another. So let's move on to talk a little bit about compliance frameworks and standards. So except for having the obvious need for security, because we don't want to face an intrusion and be put out of business for it. And there are also several laws and regulations that simply provides rules or guidelines that organizations simply must comply with, and failing to comply can result in financial penalties. So there is a whole lot of acts, and there are different acts in different nations, but I just want to exemplify with the Federal Information Security Management Act of 2002 that specifies security standards for U.S. government systems and contractors to the U.S. government. We also have the Gramm-Leach-Bliley Act, or GLBA, that establishes that financial institutions must ensure the security and confidentiality of customer information. There are, of course, a lot of other compliance frameworks, such as the GDPR, the regulations in the US that decide how we can work with personally identifiable information or personal health information and stuff like that. So just know that there are many compliance frameworks out there that your organization must comply with, and well, be sure to comply with them. Now we will move on to risk management. And risk management involves the selection and specification of security controls for an organization, and it's Basically, the idea is that we should not blindly run into security work and start implementing a lot of cool technical stuff. We should look at our organization, see what risks there are towards our organization, assess them, and have a strategic thinking about what risks to handle and in what way. I believe that this picture is from the NIST guidelines for risk management, but whatever, this is one approach given here. Which starts with a risk identification process where you try to identify the assets you have, the vulnerabilities to those assets, and the threats that are to your organization. Once we identify the risks, we can do a risk assessment, and this is the process of scoring, weighing, and prioritizing the risks. And the idea here is that we are controlled by money, everyone is, like it or not, and we want to get as much bang for the buck as possible. So we, of course, want to implement the actions or the measures that give us the most. So once we assess the risks, we go into risk response planning, and here we determine risk response, and there are, of course, different actions that we can take. We can do technical measures, we can do backups, we may buy some insurance, and some risks we are perhaps just forced to accept. We may need to have a new fire extinguishing system, whatever. Once we plan the responses we want to make to the risks, it's time to implement the measures that we decided on, and then of course monitor and assess results. And this is a wheel, so this is not a linear process that has an end. We should continuously work with risk management and continuously work in this cycle to always detect and manage the risks that are current. Okay, so that's that on risk management. We actually give a course on that here at the University of Skövde that will be given in English from starting from the fall of 2020. So next we have the vulnerability management lifecycle, and as described by NIST, vulnerability management is a security practice designed to proactively prevent the exploitation of IT vulnerabilities that exists within an organization. And for this we have a lifecycle that begins with discover, where we inventory the assets across the network, see what assets we have really. And we should do this on a regular and automated schedule. So we should have systems in place that allows us to continuously discover and look for vulnerabilities. Then we should prioritize assets. We should essentially classify what the assets that we have and group them based on their criticality to the business operations. So it goes without saying that safeguarding the production line is, no matter what you think about it, more important than safeguarding the ability to buy cake for Friday parties. Then we have the assess step, and this is where we determine a baseline risk profile, and the idea here is to eliminate risk based on asset criticality, vulnerability threats, and asset classification. So, of course, we will make sure that we handle the risks that are high and that are high towards critical assets first. Then we have the report step, and this is where we measure the level of business risk associated with assets according to our security policies. We should document the security plan, monitor suspicious activity, and describe known vulnerabilities. Remediate, where we prioritize according to business risk and address vulnerabilities in order of risk. So we remediate risks that we need to remediate. Then we verify that the threat has been eliminated using follow-up audits. And then it all begins again. Again, a circular approach, because vulnerabilities come and then we have to make them go. I also have a slide on asset management. And asset management involves the implementation of systems that track the location and configuration of network devices and softwares across an enterprise. So we basically try to have a system in place that tracks our asset automatically. And what we essentially want to do here is make sure that we collect the current state of all authorized devices. So we know how they're configured, their patch profile, if they're up to date, so on and so forth. And then we also specify the desired state of those devices. And the idea is, of course, to make sure that And the idea here is to have a profile that says that a client should look like this, server should look like this, so on and so forth. And then we find discrepancies between the current state and the desired state, and then we correct discrepancies, either accepting risk or updating policies. And then it all begins again. So let's end with a few slides on configuration management. So many different devices makes it, having many different devices in the network makes it hard to manually manage device configuration. So using configuration management software makes it easier to maintain an inventory of devices and what software that is installed on them. So the idea here is basically that we have configuration management software that maintains an inventory of our devices and lets us control what software that's installed on them, stuff like that. So some popular tools include Ansible, Chef, Puppet, and SaltStack. You can read more about those in detail if you feel like it. So just as it's hard to manage configuration, it's important and hard to manage patches. And we need to have a structured way of handling patches to ensure that systems are up to date, especially with security updates. It's usually very quick. Whenever a new vulnerability is found in some operating system from a large manufacturer, they usually release a patch rather rapidly, and then we need to ensure that it's sent out to all of our affected devices. And what patch management systems do is that they can keep up with new patches and the status of devices in the system and apply new patches, of course. And one such tool is the SolarWinds Patch Manager. So then we have the Information Security Management Systems, or ISMS, and ISMS consists of management frameworks through which an organization can identify, analyze, and address information security risks. And ISMS is basically a set of practices that are systematically applied by an organization to ensure continuous improvement in information security. So these are basically standards and practices and frameworks for a systematic information security work. And I just want to mention two of the major frameworks. So first we have the ISO 27000 family, where we have 27000, 01, 03, 04, 05, where the first one is an overview and vocabulary standard. The second one is for information security management system. And then we have implementation guidelines, we have measurement, which is a discussion of metrics and measurement procedures, and then we have risk management. So that's the ISO family. Very brief, just to know that it's there, and it's a very popular standard of family to follow, at least in the Europe and that part of the world. And then we have the NIST Cybersecurity Framework. And this is basically a framework of a set of activities suggested to achieve specific cybersecurity outcomes. And it has some core functions, and those are the core functions that are written up in the figure here. Where we'll first have identify, which is the function of developing the organizational understanding to manage cybersecurity risks to systems, assets, data, and capabilities. Then we have the protect function, where we develop and implement the appropriate safeguard. Then we have the detect function, where we develop and implement the appropriate activities that we need to identify the occurrence of a cybersecurity event. Then we have the respond function that cares about how we respond to a detected cybersecurity event, and recover, where we develop and implement the appropriate activities needed to maintain plans for resilient and restore any capabilities or services that were impaired due to a cybersecurity event. And you can find more about both of those frameworks or standard families freely available online. So that sums up chapter number 10, and I will basically see you next time for chapter number 11. So have a good one.